As we move into the last two lessons of Chapter 13, we're really going to focus on the 6 trig terms in any of the 4 quadrants. Here's Lesson 13.3, trig functions of any angle. As we create an angle, it could rotate into quadrant 1, 2, 3, or 4. And the location of the terminal ray is going to matter. When we create a triangle, we have to be consistent with process. That means we're always going to connect our terminal ray straight down to the x-axis. And then we can apply the following definitions in the blue table on the left. If we think of our terminal ray as a length of r, what we can do is pick a coordinate on that terminal ray and use that to find the length of r, no matter what quadrant we end up rotating in. Now sine, cosine, and tangent are going to be our more common definitions that will apply. Sine is y divided by r, cosine is x divided by r, and tangent is y divided by x as long as x doesn't equal 0. That would be a restriction. The cotangent, secant, and cosecant definitions are again just the reciprocals for sine, cosine, and tangent. The other thing to note that when we create our r value, that answer is always positive, but x and y could be negative. This will help us decide when our trig definitions are positive and negative in any of the given quadrants. Here's a little chart that kind of helps break down when our trig definitions are positive or negative. In quadrant 1, if you plotted a point for x and y, both coordinates would be positive. Since x and y are positive and the r value would automatically be positive, all 6 trig functions have a positive value in quadrant 1. But as we move into quadrant 2, notice you would count to the left on the x-axis and then up for y. Any function that has x in the formula has to be negative, but any function that has just y would stay positive. So notice in quadrant 2, sine and cosecant will be positive because that's y divided by r. Cosine and secant would be negative because they're related to x. And because tangent and cotangent have y and x in the definition, they stay negative as well. Let's take a look at quadrant 3. Unique thing about quadrant 3, both x and y are negative. Again, meaning anything that has x or y in it would also be negative. Sine and cosecant would be negative. Cosine and secant also negative. But check out tangent and cotangent. They're y divided by x. And if you have a negative divided by a negative, your answer for that trig term would actually change to positive. And last but not least, in quadrant 4, you count to the right, but then you count down on the y-axis, making the y-coordinate negative. This would make sine and cosecant negative, but cosine and secant are positive, and then tangent and cotangent are negative. This chart is just kind of a quick reference to make sure we're plugging in the correct values, putting our points in the correct quadrant, and determining when things are positive or negative. Determine the quadrant or quadrants where each statement is true. Sine is less than 0 and tangent is less than 0. We want to know when is this true for both statements at the same time. Let's start with sine. If sine is less than 0, that means it's going to be negative. And sine's related to the y-coordinate. Y is negative in quadrants 3 and 4. That means sine is negative in quadrants 3 and 4. Tangent less than 0 means tangent would have to be negative as well. And tangent is negative in quadrants 2 and 4. We want to determine what quadrant or quadrants works where each statement is true. Notice there's only one quadrant where both statements are true at the same time, and that would be down in quadrant 4. That's when both of those statements would be true. You try the next one. Pause the video and create an xy axis. Determine when cosine is greater than 0 and when cotangent is less than 0. See if you can determine the quadrant or quadrants where that statement is true at the same time. Did you get quadrant 4 again? I have cosine is greater than 0, which means it's positive, and that was true in 1 and 4 because it's related to the x-coordinate. When you count to the right, x is positive. Cotangent is less than 0. Well, remember, that's just like when tangent's less than 0. They match up. That would be in 2 and 4. So the unique thing about this answer is it's quadrant 4 again, but that's not always going to be the case. For the final example, when is sine theta greater than 0 and cosecant theta less than 0? If sine is greater than 0, that means it would be positive. Since sine is the y-coordinate, it's positive in quadrants 1 and 2. Okay, so this one's unique. Cosecant is less than 0, which means cosecant is negative. But cosecant is only negative when sine is negative, and that's in quadrants 3 and 4. So is there a quadrant where both statements are true at the same time? No, this one's not possible. We can't have a function and its reciprocal in the same quadrant that have opposite signs. They always have to match. We're going to finish the lesson today with these two examples. Let each ordered pair be a point on the terminal side of theta in standard position. Find the exact values of sine, cosine, and tangent theta. The first thing we're going to do is plot the ordered pair, -2, 5. So that's like x and y. I'm going to sketch my graph, but I'm not going to be super particular about counting out the dashes. -2 would be to the left and 5 would be up. I'm simply going to pick a point somewhere in quadrant 2 as my coordinate -2, 5. Then what I'm going to do is connect my terminal ray, so from the center, connect it up to that location, like so. Technically, what we've done is we've rotated from that right-hand side in that clockwise or counterclockwise direction over to quadrant 2. But as we think about creating a triangle, remember I talked about creating a triangle to the x-axis or creating that right angle? So what I'm going to do is I'm just going to draw a segment straight down and create a right triangle. Now I know my original theta is on the outside, but what I'm going to do in this triangle is connect it to the center of the coordinate system. So that's going to be the angle within our triangle. And I know that we went -2 to the left. I'm going to mark 2 as my direction, 2 as my length, but negative as my direction. And then we counted up 5 to get to that point. From here, we just need to figure out the r value. And remember up above it says r equals the square root of x squared plus y squared. Ultimately, it's Pythagorean theorem. If we plug in r equals, x is -2, and it's important to note that we're going to square that. And y is 5, so that's 5 squared. When we square -2, we get +4, so be careful on that. And then 5 squared is 25. 4 plus 25 is 29. Now, 29 is a prime number, so that means we can't simplify the square root. But it also says in the directions that we want to have the exact values, so no decimals here. We're going to keep r as the square root of 29. All right, so our definition for sine is y over r, which is also opposite, over hypotenuse. The y value was 5, and the r value is square root 29. Whenever we have that square root in the denominator, we have to rationalize, which means we're just going to multiply again, top and bottom, by that square root. If I multiply straight across, we get 5 square root 29 all over 29. That's the exact sine value. I'm going to go ahead and slide cosine and tangent down here. I thought I'd have enough room, and I guess I didn't. So I'll put cosine right underneath. Cosine, by definition, on the coordinate system is x over r. And the x value is -2. R stays square root 29. When we rationalize here, we get -2 square root 29 over 29. The last one's tangent. And the nice thing about tangent on this one, it's y divided by x. So we don't have to worry about the square root of 29 in our answer. Y divided by x is 5 over -2. If we would have been asked to do the other 3 trig functions, cosecant, secant, and cotangent, we would just take the reciprocal of these 3. Okay, everybody, what I'd like you to do is draw the picture that would represent this coordinate, and that should be a comma. I don't know why that's there. -3, -7. Could you plot that in the correct quadrant and then determine the value of r? Do that first and then press play, and we'll finish the problem from there. Did you get r equals square root 58? I know 2 goes into 58, but I think that would just be 2 times 29. So that doesn't simplify, but again, we're not doing a decimal approximation because the answer says find the exact value. All right, I'm going to have you pause the video again. Can you determine sine theta? I'll throw my little theta in here. Remember, theta is always going to be inside the triangle at the center. And then we'll do cosine theta and tan theta. See if you can try those 3 definitions to determine the exact value from theta. Press play when you're done and we'll call it good today. For sine, I got -7 times the square root of 58 divided by 58. Cosine is also negative. Notice it's -3 square root 58 over 58. And check out tangent, everybody. If you apply y divided by x, you get -7 divided by -3. Recognizing that those 2 negatives would cancel, and you'd get +7/3 as your answer. If you look at that chart up above in quadrant 3, you'll notice that sine and cosine should both be negative and tangents positive. So our work here is correct. This is lesson 13.3.